Now that we can simplify radicals, we can derive distance formula. So if I want to find the distance between 2 points within the Cartesian plane, between point A and point B, well, within our Cartesian plane, we have to consider, well, we have a horizontal distance of our x values, and we have a vertical distance of our y values. Instead of taking a straight line path from one point to the other, we can consider an alternate path, where we travel along the x-axis, certain number of units, and then we travel along the y-axis, another number of units. That creates a right triangle connecting those three paths together. Now, if we're traveling along the x-axis, we start at x1 and we end at point x2. The distance between those 2 points is the difference between x2 minus x1. And then if we travel along the vertical axis, we start at y1 and we end at y2. And again, to find the distance between those two is the difference between y2 and y1. So x2 and x1, y2 minus y1, that forms the two legs of my right triangle. My distance is my hypotenuse. So using our Pythagorean theorem of a squared plus b squared equals c squared, our two legs are x1 minus x, or x2 minus x1 squared and y2 minus y1 squared equals our distance squared. Since we're solving for distance, we want to get rid of the exponent on the distance so that we have a formula that is just solving for distance. Well, if we square root both sides of our equation, we're left with distance equals the square root of x squared minus x, or I'm sorry, x2 minus x squared, y2 minus y1 squared. Note how these exponents do not cancel. This is our formula for distance, and how we derived it from the Pythagorean theorem. Once we know how to derive it, we'll always be able to use it. Our distance is going to be equal to the square root of the differences squared for x and y. It doesn't matter which is your first point and which is your second point, as long as you're consistent. So our distance equals the square root. We have 1 minus 2 squared, negative 4 minus negative 5 squared, negative 1 squared plus 1 squared. Our distance equals the square root of 2. That is our exact value. We cannot simplify that radical any further, so we leave it. 3 decimal place approximation, so if it's asked for, we can round it. So we just plug the value into our calculator, and the square root of 2 is approximately 1.414 when rounded to 3 decimals. Now, midpoint gives us the point that is located exactly halfway between two endpoints of a line segment. Now, just as a note, we need knowledge of roots for distance, but we don't need it usually to calculate midpoint, unless one of our values is a radical for one of the ordered pairs, which is a possibility. But since the two are often confused, it's a good idea to review midpoint here so we can make sure that we clearly understand the distinction between the two. So let's think about midpoint of a number in 2 dimensions. Let's consider our number line, and we have the number 2, and we want to consider the number that's right in the middle. Well, the number that's directly in the middle of the 2 is 5. We want to think about how we can take a mathematical equation with 2 and 8, and we end up with an answer of 5. Well, a lot of students think to start, they say, well, what about 8 minus 2? Well, that gives me 6. That doesn't give me 5, so that doesn't work. Well, if we take 8 and we add 2, well, that gives us 10, but 10 doesn't give us 5. But if we then divide by 2, we get 5. And so the way that we found the midpoint is we took the x values, we added them together, and we divided by 2. This is just finding the mean or the average of the 2 points. We found the average of 2 and 8. We add them together and we divide by the number of points. So if we can do that with x values, we can also do that with y values. We can add the y values together and find the average of the y values. So midpoint is just the average of the x and y coordinates. So we want to find the midpoint of these two. We take the average of the x values, and we take the average of the y values. Negative 2 over 2, 3 over 2, reduce where we can. If it's a rational number, you can write it as a decimal as long as it's terminating, or you can leave it as a fraction, and there's our midpoint. Remember, distance measures the distance between 2 points, so we'll use units to measure that, but midpoint is another point halfway between two values. So make sure you can separate what the two different things are finding.